let's revisit the Thevenin's equivalent circuit. Okay, so if we have a network, then that network is equivalent to VTH, which is your open circuit voltage across these two terminals, in series with RTH, which is given by your VTH upon your short circuit current, your current which flows through these two terminals when they are short circuited is your short circuit current, and VTH upon ISC is your RTH. Okay, now if you recollect the source transformations we had seen, whenever we had a voltage source in series with a resistance, we can always convert it or transform it into a current source which is having the same resistance in parallel, and the strength of this current source is given by V upon R, right? So this particular equivalent Thevenin's circuit we can transform into a current source with a resistance in parallel. Okay, that particular current source is going to have a strength of VTH upon RTH, okay, which is basically equal to your, just see over here, your VTH upon RTH is equal to ISC, right? So the strength of this current source is equal to ISC, and it has RTH in parallel. Okay, so this type of a equivalent circuit is known as your Norton's equivalent circuit. Okay, this is your Norton's equivalent circuit, and this particular current source is known as your Norton's current IN. Okay, IN is equal to your ISC, and this particular resistance is known as your equivalent Norton's resistance and is known as RN, which is equal to your RTH. Okay, and now if you have a load resistance connected like this, okay, then how you're going to find out the current through this RL? Let's say I connect this load resistance like this, then basically what you have is a current source and two resistances which are in parallel. Okay, so as per your current divider rule, your current through RL, let's just say this is I, is equal to what? It is equal to your net current, which is your IN, into your equivalent resistance, which is RL dot RN upon RL plus RN, divided by your RL. Okay, so you have by RL. So this RL and this RL would be eliminated, and what you're left with is your current which is flowing through your load resistance is equal to IN, which is equivalent Norton's current, into RN upon RL plus RN. Okay, and this particular statement, if you are going to say it in words, is known as your Norton's theorem. Okay, so this is your Norton's theorem, which tells you how to find out the current through a load resistor by converting the circuit into a equivalent Norton's current with a Norton's resistance in parallel. Just realize this Norton's resistor is same as your Thevenin's equivalent resistance. Okay, so just the way you are going to calculate your RTH, you are going to calculate your RN. Okay, there is no difference between RTH and RN. Okay, so you are going to calculate your RTH and say that it is your equivalent Norton's resistance. Okay, and this short circuit current, how you are going to calculate? This IN is basically the short circuit current, right? So in order to calculate IN, what you're going